And here's the second part to soil physical properties, part B, on how to describe soil horizons in the field. So this will be again useful for assignment 2. So in part A we went over color, texture, models, structure, and consistence. And in this part we're going to focus on coarse fragments, roots, and horizon boundaries and thickness range. So coarse fragments, you had a little bit of exposure to this. Of course, it's any fragment or particle greater than 2 millimeters, not to be mistaken with soil PEDs, which are aggregates of primary soil particles, mostly the fines. So what you're going to do is you're going to estimate the percent of coarse fragments greater than 2 millimeters in diameter. This schematic can give you sort of a helpful hint as to what these different percentages look like. It would be really tricky to do in the field. Often a lot of your field notebooks, the waterproof ones, sometimes they have these embedded in them, but we'll provide you with a handout of this as well in the field. Now on to roots. So roots are going to be estimated by diameter class. So coarse roots are greater than 5 millimeter, medium or 2 to 5 millimeters in diameter, and fines are less than 2 millimeters in diameter, not to be mistaken with soil texture. For fine roots, you want to base your estimate on a 2.5 by 2.5 centimeter square. So just in your soil pit, do a few 2.5 by 2.5 centimeter squares and count how many fine roots are in there. For the medium and coarse roots, you're going to use a 1 by 1 meter square, or as close as that as possible. Sometimes it's absolutely impossible to do that, so you need to scale down your area and then scale up your results. Now the density categories are grouped as such. You will quantify fine, medium, and coarse as few, plentiful, or abundant, depending on how many roots you find in each of these classes. So for instance here, this should look familiar. This was in the logger sports field. You would only primarily have most of your roots probably in this A horizon, and lower down in the B there were a lot fewer roots because it was so compacted, right? So you're going to then estimate the diameter of some of these roots and figure out what size class they're part of. Are they fine, medium, or coarse? And given that this is not a 1 by 1 meter area, you're not going to be able to do that. So perhaps you'll do a 20 by 20 centimeters area. And then you're going to have to do a little bit of math to scale that up to what it would be equivalent to in a 1 meter by 1 meter area. We can help you with that in the field. Now, horizon boundaries. Horizon boundaries aren't always very distinct, nor do they have a very horizontal or regular kind of form. So we're going to describe horizon boundaries as distinct, by their distinctness and their form. So distinctness can be described as abrupt, clear, gradual, or diffuse, and the form is whether it's smooth, wavy, irregular, and broken. Here are the details for each, and I'll let you look at that when you're in the field. So for instance, check out this soil profile. I'd say that the boundaries are quite clear. You can see when there's a pretty distinct change in color and probably some other soil properties between the A, B, and the C horizon. So what you then see here is that the shape, however, is a little bit wavy. So that's how I decided to characterize these soil horizons. Here are some other examples. This one is very wavy, and sometimes you'll notice how it's sort of really, they sort of bleed into one each other. So that's what we're looking for, is to characterize that using the terms that I gave you. And here, this one is quite gradual. You know, it's hard to discern the difference between one horizon and the other. But check out how it's generally quite sort of a very, not so wavy. I can't remember what the word is, but there you go. So lastly, thickness range. So I talked about this a fair bit in the video on conventional soil pedon descriptions. So here what you're going to do is take an average of the thickness of the soil, and you're going to report that as part of your soil pedon description. So what you do is you place your measuring tape at the top of the mineral horizon and get some estimates for each horizon. And all this information from Part A and Part B are going to fit into a really nice description, and here's how we're expecting you to do it. We're not that interested in the soil modifiers. This is very detailed work, but we're interested in seeing the formatting scheme here as well as the terms that we were discussed in Part A and Part B of these videos. That's it.